Okay, crew, you're going to think I'm absolutely crazy. I'm actually sitting here at the tail end of the parent-teacher conferences trying to put this together. And what we're going to be talking about is ionic compounds again. And in particular, we're going to talk about how to create formulas and name ionic compounds when the ions themselves have multiple oxidation states. And by that, I mean that they have multiple ions that they're commonly found in. So, typically, these are things that are metals that are found in the transition elements, or the transition block of the periodic table. And the ones that are the most common in terms of ones that have multiple oxidation levels include manganese, which has a charge of +2 in some cases, but also can be commonly found with a charge of +4. Iron, which has a 3+ charge, but also can be found in a 2+ form. Cobalt, bad Chang. Cobalt, which can be found in a 2+ form or a 3+ form. Nickel, 2+, 3+. Copper, 2+, or copper plus. Now, the ones that I've listed here on the top, so let me just go back and underline these ones in red. These are the ones that, more often than not, you would find the ion in that particular form. Okay, so more often. What's that? Yeah, nobody's here for me. And this is going to be, obviously, it's going to have a significant impact on how you combine elements or combine the atoms in an ionic compound. So, for example, let's say for a moment that we want to make combine iron with a 3+ charge with a chlorine or chloride ion with a -1 charge. Now, if we do the crisscross method, you have no problem understanding that you simply need to take the number associated with the opposite charge and put that below as a subscript. So it would look like Fe with a 1, Cl3. And that's exactly what it would be. However, naming this now becomes a little different, since there are two different versions that you could have here. Because obviously, let's say instead of having the 3+ charge on the Fe, I decided that I wanted to combine the 2+ version of the iron cation with chloride. Chloride's not going to change, it's always the same. Now, if this is the case, I'm going to be bringing a different number into the subscripts. And instead of being FeCl3, I'm going to have FeCl2. If we just called this iron chloride, there would be no way that you could distinguish between the iron chloride that has 3 chloride ions versus the iron chloride that only has 2 iron chlorides. So, to be sure that we can name these properly, we would actually use Roman numerals when we do this. So in this first case, it's going to be called iron, Roman numeral 3 in parentheses, chloride. And the 3 obviously very much refers to the fact that we have a 3+ ion associated with this. So I think you could imagine, it doesn't take much to understand this one, or that you have this as iron 2 chloride. Whoops, make that chloride, not carbon. So, that's a piece of cake, right? Now, imagine if I were to give you the reverse here. Now, don't forget that we know that manganese can be a +2 or a +4. What if I had this? If I said we had manganese, it's a G there, 4 bromide. It's just strange that I'm writing in lowercase. I can't even do it. Manganese 4 bromide. And I asked you then to give me the chemical formula for manganese 4 bromide. Now, this has to clue you in right away. The 4 indicates that that's the actual charge associated with the atom. So you know that it's going to be Mn 4 plus. You also know that bromine is going to form, it's a halogen, so it's going to form a -1 ion, or bromide ion, so that'd be Br -1. Okay, so we are able to sort of crack the code with this. And then we do the same thing we keep doing, which is transfer, do the crisscross, transfer the either assumed or actual absolute value of the charge, and then we're left with Mn Br 4. Okay, so manganese 4 bromide. All right. Now what happens if we introduce a polyatomic ion? Let's say I'm going to do the polyatomic ion phosphate. Oops, I don't know what happened there. So we have PO4 3 minus as my polyatomic ion. And this time I'm going to take, let's say, nickel. Okay. And if nickel has a 3 plus charge, this is going to be super easy because it's simply putting these two things together. Voila. Okay. However, if instead I decide that I'm going to use the nickel with the 2 plus charge, okay, so this is going to be nickel 2 phosphate that I want to make here. And I need to make sure that I do the crisscross here. Then I have the nickel piece with 3 as my subscript, parentheses PO4 with a 2 as a subscript. So that's how I show nickel 2 phosphate. Don't forget these, right? It's vital that you include the parentheses so that you know that this subscript applies to everything inside of those parentheses. Okay, so ultimately you always need to be on the lookout for these funky transition metals. Actually, I left out one of them, which is often used, and that is chromium, which can form a 3 plus most often, or chromium, which forms a 2 plus. So this is the one that you'd more often find chromium in. All right. Get ready for tomorrow, you guys, because I'm going to be having you work in groups to solve a whole bunch of problems related to naming ionic compounds, as well as putting together formulas for both monatomic and polyatomic ionic compounds. Good. All done. Bye.